All right, section 8.4 is all about the triangle proportionality theorems. So our objectives are to use the triangle proportionality theorem and its converse, also to use the other proportionality theorems. And our essential question, what proportionality relationships exist in a triangle intersected by an angle bisector or by a line parallel to one side of the sides? So our first theorem is the triangle proportionality theorem. It states, if a line intersecting a triangle is parallel to one side of the triangle, as you can see here in the illustration, here's our line that is parallel to the side of the triangle, then it divides the sides proportionally. It's talking about these sides. Shorten that down to our implied statement. Parallel line to a triangle side implies proportional sides. So if we're looking at the illustration we have here, the diagram that we have, we can say that if TU, so that segment here, is parallel to QS, which is the side of the triangle, then the sides are proportional. So that's these sides. So RT compared to TQ equals RU compared to US. So you kind of break up your sides into parts, and they are proportional. All right, let's take a look at two examples where we can apply this theorem. Our first example, what is the length of RQ? So we're trying to figure out this missing side length. Well, knowing that QS is parallel to the side of the triangle, which is UT, that makes this side, or this segment of the side compared to this segment equal to this segment over this segment. So start by setting up a ratio equal to a ratio, which is a proportion. So we have RQ divided by 9 equals 4 divided by 6. And we're looking for the length of RQ. So here's where you do your cross products. So you end up with RQ times 6 equals 9 times 4, which is 36. Next, you'll divide 6 on both sides. So the length of RQ comes out to equal 6. All right, let's take a look at our next example. We want to determine if segment PS is parallel to QR. All right, quick fix. We want to determine if segment QS is parallel to segment UT. So in order to do that, we've got to see if our side segments are proportional. So start by setting up a proportion. We have 90 divided by 50 equal to 72 divided by 40. Next, we see what common factors can reduce our fractions. So 90 and 50 both have a 10 in common. So that simplifies to 9/5. 72 and 40 have an 8 in common. So those two numbers will reduce to 9/5. And what we see is equal ratios. Therefore, we can conclude, since we have a proportion, that the lines are parallel. Our next theorem is the three parallel lines theorem. And it states that if three parallel lines intersect two transversals, so we have 1, 2, 3 parallel lines intersecting two transversals, then they divide the transversals proportionally. Implied statement shortened down to 3 parallel lines intersecting two transversals implies proportional segments. So we can see that YW compared to UW, or WU, is equal to VX compared to XZ. All right, so let's check out the theorem in action. Let's find the length of segment AB. So we have 3 parallel lines, and we know that because each of these lines are all perpendicular to the same line. So therefore they are parallel. So our three parallel lines are intersecting two transversals. So that means that we have proportional sides and segments. So set up a proportion. So we can put 16 divided by x in the same ratio equal to 15 and 18 in the same ratio. So we're ready to do our cross multiplying. So 16 times 18 is 228, and 15 times x is 15x. Next, we're ready to divide both sides by 15, resulting in x equaling 19.2. Our next theorem, triangle angle bisector theorem, states that if a ray bisects an angle of a triangle, so here we have our ray bisecting angle C of our triangle ABC, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So what we're saying is when this angle bisector cuts through the opposite side, the segments that are created from the intersecting of the bisector to the side is AD over DB equals AC's length divided by CB's length. Or you could also write a different ratio that states AD divided by AC equals DB divided by CB. Now let's see this theorem in action. Find the length of segment RS. So first start by setting up a proportion. We see that QR, since PR is our angle bisector, it's cutting through this opposite side, so QR divided by RS equals PQ divided by PS. Next, we would substitute expressions or values. So in place of QR, we would put 15 minus x, because we know the full length from Q to S is 15. Since this is x, then this must be the difference of 15 and x. So we have an expression, 15 minus x, replacing QR, and then x represents RS, and 7 represents PQ, and 13 represents PS. Remember to place all expressions in parentheses so that when you're ready to do your cross products, you remember to put the parentheses and distribute the 13 in this case. So we have 7x equals 13 times 15 minus x. So next we'll distribute the 13 to the 15 and the x, resulting in 7x equals 195 minus 13x. Ready to combine like terms, so we'll add the 13x to both sides, resulting in 20x equals 195. Next, we will divide 20 on both sides, resulting in x equals 9.75. So the length of R to S is 9.75. All right, this concludes all of the theorems dealing with triangle proportionalities. So now try all of the rest of the problems on your notes page by yourself, applying all of the different theorems, and see how you do. We will go over them in class.